All right, everybody, we made it. It's the last video of the chapter, and today what we're going to do is build on what we did yesterday, which is using our calculator to get these linear models based on lines of best fit, and then we're going to use that to predict what's going to happen. So just like we did with word problems, where we spent one day just writing the equations and one day using them to calculate things, we're going to do the same thing, only now the calculator is giving us those equations instead of us writing them ourselves. So a woman is considering buying a used car. She researches prices for various years of the same model and records the data in a table. Is a price of $4,200 for a car made in 1999 reasonable? And estimate the value of the car in 2007. Now we actually used this exact data yesterday in our linear model. What we said was that when the model year, or the x's, are years, we make the first one 0, and then we just count after that. So 2003, since it's 4 years or 3 years after 2000, would be worth 3. Now you do need to be a little bit careful here because sometimes we skip years. For example, if 2001 was missing, 2002 would still be 2 because it's 2 years after the year 2000. So you have to be a little bit careful about that. 2 doesn't necessarily mean it's the second number. It just means it's 2 years later. All right, so if we type in this data on our calculator and we get our line of best fit, let's start with this. Let's define our variables. So x is going to be the year since 2000. So 2007 would be 7 years later. Y is going to be the price. And if we type our data in, we're going to go to Stat, Edit. I've already got the data typed in because I had just finished this problem, and so now I'm making the next video. If you need a second to type in this data, go ahead and do that now. You can pause the video or whatever you need to do to make that happen. Then we would go to Stat, Calculate, Option 4, Enter, 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 Enter. And so our equation would be y equals 1325x plus 5645. Now it says here, is a price of $4,200 for a car made in 1999 reasonable? If the year is 1999, that would be an x value because the years are all of the x values. And since it's 1 year before the year 2000, its value would be -1 because to go from 2000 to 1999, I would go backwards 1 year. So if I plug that number in for the x, I would have y equals 1325 times -1 plus 5645. Now if I type that into my calculator, I've got 1325 times -1 plus 5645, which is 4320. Now the problem says, is asking $4,200 reasonable? Well, I just figured out that I would estimate the car is worth $4,320. So $4,200 is actually a pretty good deal. I'm being asked to pay less than what it's worth. So I would say, so yes, the price is reasonable. Because if they only want to charge me $4,200, I'm coming out ahead. My car is actually worth more than that. Estimate the value of a car in 2007. So now because 2007 is a year, that's going to be an x value. And the number it's worth is going to be 7 because 2007 is 7 years after the year 2000. I should probably put like a little line there to show that those are two different things. So y equals, I'm going to do 1325 times 7 plus 5645. And if I type that in, 1325 times 7 plus 5645, I get $14,920. So I would estimate that in 2007, that car is going to be costing me $14,920. Problem number 2 is again a problem we actually wrote the equation for yesterday, and now we're going to use the equation to do other things. So it says the numbering system used in Europe for shoe sizes is different than the system used in the US. Use the data in the table to create a model for converting between the systems. So X would be my first row, Y would be my second row. Let's define our variables. X would be the US size. Y would be the European size. And now I'm going to type the data into my calculator and get my estimate. So, stat, edit, I'm going to clear these lists. So I'm going to go up to the list name, hit clear and enter. I'm not going to hit delete because delete will ruin everything. And now I'm going to go 1, enter 3, enter 5, enter 7, enter 9, enter 11, enter. And in the next column, 31, 34, 36, 39, 41, and 44. Now once I have all my data typed in, I'm going to go to Stat, Calculate, Option 4, Enter, 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 Enter. And I'm going to get Y equals 1.27x plus 29.87. Now it says here, find the European equivalent of a US size 8. Since US sizes were X values in the table, I'm going to plug in an 8 for my X value in my equation. So Y equals 1.27 times 8 plus 29.87, which would give me 1.27 times 8 plus 29.87, 40.03 as my answer. Now part B says find the US equivalent of a European size 43. Now because the European sizes were Y values in my table, this is going to be a Y value in my equation. So I'm going to write 43 equals 1.27x plus 29.87, which when I solve that gives me, if I subtract the 29.87 on both sides, I would get 43 minus 29.87, which is 13.13, equals 1.27x. Then I would divide by 1.27. And 13.13 divided by 1.27 would be 10.3, and then the 8 is going to round up the 3 to a 4. So it would be about a size 10. All right, last one. The table shows the relationship between calories and fat in various fast food restaurants. How much fat would you expect a 330 calorie burger to have? All right, now again, first row is going to be X. Second row is going to be Y. We're going to define our variables. So X equals the number of calories, and Y equals the amount of fat in grams. We're going to use our calculator to get our line of best fit. So I'm going to go to Stat, Edit, clear both lists by going up to the name, hitting clear and enter. Do not hit delete, it will ruin everything. And I'm going to type in 720, 530, 510, 500, 305, 410, 440, 320, 598. In the next column, I'm going to type in 46, 30, 27, 26, 13, 20, 25, 13, 26. Now I'm going to go Stat, Calculate, Option 4. And I'm going to get Y equals, if I read these numbers right, it's 0.07x minus 9.2, and then the 8 is big enough to bump up the 6 to a 7. Now it says in part A, how much fat would you expect a 330 calorie burger to have? Because calories are my first row, they are my X values in my table. So they're going to be values that I substitute for X in my equation. So I'm going to have Y equals 0.07 times 330. minus 9.27. 0.07 times 330 minus 9.27. 13.83 would be my answer. And fat is measured in grams, so I would put grams. How many calories would you expect a taco with 22 grams of fat to have? Now, grams of fat are the y values in my table, so they're going to be the y values in my equation. So I would have 22 equals 0.07x minus 9.27. Now I'm going to add 9.27 on both sides. And I'm going to get 31.27 equals 0.07x. Divide by 0.07. And I would get 31.27 divided by 0.07. I would get 446.71 calories would be expected if I knew that I had 22 grams of fat. Okay, that's it. Thank you so much for watching. We will practice this tomorrow, and then we will get started on all of our experiments, which should be super fun. And I'll see you then.